Hey everyone, I am Dipanshu and welcome to my first video here on YouTube. I am a software engineer who loves simplifying complex topics, and what's better way to start this journey than with threads? One of the most fascinating and sometimes confusing part of the Java. So if you're new here, hit that subscribe button and let's learn and grow together. So as I said earlier, today we are diving into something every Java developer should know, and that is called threads. Stay tuned because by the end you will understand how to make your Java apps run smoother, faster, and smarter with a dash of multi-threading magic. So in this video, we will talk about threads. And now, what are threads? Now think about this. When you run the application, of course, the software which you have written and someone else written, we don't care about it. So basically, it will be running on an OS. So let me draw it first. It will be running on some operating system. Let's drink it, right? And below the OS you have a layer which is called hardware. And this is hardware, right? So this is basically we normally represent with software build. Now let's say this is your software, and this software basically it run on OS, and you will have multiple softwares on this OS. So like this, consider these as a multiple softwares. Oops, let me yeah. So basically these are your softwares. Let's say SW1. Cannot, yes. Yeah, this is software 1, this is your software 2, and this is again your software 3. Right, so these all are running on the same OS. So this is where you have the physical set. Now you have the CPU, you will be having a RAM. Let me draw it first. Here is your, let's say, CPU. Oops. Now this is your CPU, and here is your RAM, right? So basically RAM acts like a temporary memory for your processing, and your CPU is basically something which executes something. Okay, we don't know it right now. So let's say in your software, even if you want to add two numbers, like I'm giving my OS this command 2 plus 2. Let's keep it very simple. And if let's say if you want to add two numbers, and we just saying 2 plus 2. Now that operation, basically that operation will go to OS, and the OS will say, okay, you want to add two numbers, let me just send the request to the CPU. So basically it send this request to the CPU. Here, hold on. Oops. Yeah, so it will send this request. It looks ugly. Let's remove this. Yeah, so now the OS send this request to CPU, and CPU says, okay, that's the task, I will just have to add two numbers, and it will do some processing, and then you get the output. So the thing is simple for every operation, for every simple operations. Now let's say if you're working with a big software, so apart from this you have multiple software which you want to run on the same OS. Let's say I just open VS Code, and if I add something, then as you see it will suggest simultaneously. Let's say, look, I've been writing on it, and at the same time it will suggesting there is some intelligence which suggests me something like this. Let's say I don't know about this. So you have seen that that is multitasking, right? So we have multitasks running at the same time. So the now today most of the modern OS support that. So the thing is, it's not like they are executing this at the same time on the CPU. For example, our software 1, 2, software 3, and let me just remove this part for the time being here. Let's just say you have 3 software here. I can remove this. Okay. So now you have seen that there are 3 software running on the same OS, and we can say this is multitasking. Sometimes, when you browse a web page and you simultaneously you can listen to music and you can type a code also, so you can do all those things at the same time because you have concept of multitasking. But if we talk about one single task, what if we want to break down this task into multiple things? And it is possible that in the same software you have multiple processes, like as shown you earlier, like this. Suppose I add class, so you know this is a single software which is Visual Studio Code, and it runs many processes simultaneously at the same time. And you can see the moment I type it, it is showing the text on the software. It is also showing this the error, right? So that means these two things are happening at the same time. Maybe we can also enable some sound effects the moment I type A to create a sound effect. So we are doing multiple things at the same time in the same software. So that means it is not just about multitasking. It is also about dividing your tasks into simple small things. So the smallest unit, that is where we have a concept of threads. So we can say that thread is basically a smallest unit of process, right? I am taking another examples. For example, you play a game, any game which you want to play, cricket or football, table tennis, on your computer. So now at that point what happens, if you talk about football, let's say we have multiple players running at the same time. So the audience is cheering at the same time, you have ball is rotating on the grounds. In fact, if you see your activity, let me just show my activity monitor. Here you see, let me, yeah, here you see activity manager on Mac, or if you go to your task manager on Windows, you can see whatever task you have. So you can see here my Google Chrome is taking 47 threads, the spotlight is 48, or some 4 threads, screenshot is 4 threads, activity monitor is taking 7 threads, like this. So every software is running, and now all are those are tasks, and individual task, if you can see, we have threads there. So the kernel is consuming, where is my kernel, the maximum threads, yeah, which is 544. So in a task as well, you have the smallest unit. The beauty is that they can run parallelly, and they are lightweight basically. So they all share the resources. So it is not like if you have 42 threads, they will consume 42 different resources. No, multiple threads can share resources. So I hope you got the gist what is threads. And just to remind, that is the smallest unit basically which you can work with, and of course you can run multiple threads at the same time. And thank you. And we will in the next video we will take a real world example. And we also trying to manipulate the threads. We setting our priority that this is my task, and give me the most threads to it, so that it can execute in the lesser amount of time, and I will get the output very quickly, apart from the rest of the tasks. We will also talk about that. And there are some threads function like threads priority, set priority, get priority, which we get the priority of some task. And then there is a concept called sleep, in which we delaying some task intention in it. I can delay this particular task, so you stop there and execute others. So there are basically various manipulative methods for threads, which we'll talk about later. So that's today. Thank you.